Es fällt mir schwer, in Worte zu fassen, was für eine bedeutende Entdeckung das ist. Was gerade in Bezug auf die Pyramiden auf dem Gizeh Plateau und das Plateau selbst bekannt gegeben wurde, ist so unglaublich, so ehrfurchtgebietend und erschütternd, dass ich hier seit einer Stunde sitze und versuche, die Auswirkungen dessen, was uns gerade gesagt wurde, zu begreifen. Dies sind so ziemlich alle Neuigkeiten, denn die neuen Erkenntnisse wurden am 16. März auf einer Pressekonferenz des Teams bekannt gegeben, das die große Pyramide von Gizeh mit einer nicht-invasiven Technologie namens Synthetic Aperture Radar Doppler Tomography untersuchte, die erstmals von Filippo Biondi und Corrado Malanga entwickelt wurde. Dies wurde verwendet, um die innere Struktur der großen Pyramide von Gizeh zu untersuchen. Diese Methode nutzt die Analyse von Mikrobewegungen, die typischerweise durch seismische Hintergrundaktivitäten verursacht werden, um eine hochauflösende, vollständige 3D-Tomographie des Inneren und der unterirdischen Komponenten der Pyramide zu erhalten. Die jüngsten Erkenntnisse aus dem Einsatz dieser Technologie sind schlichtweg überwältigend, denn man hat festgestellt, dass es riesige Strukturen gibt, die vom Fuß der Pyramide bis tief ins Grundgestein reichen, und zwar über 600 Meter tief, und die dann mit Strukturen verbunden sind, die bis zu 2 Kilometer unter die Erdoberfläche reichen. 2 Kilometer lange massive Innenstrukturen sind mit der Basis der Pyramide verbunden und erstrecken sich sehr, sehr tief nach unten. Das ist, was wir bisher wissen. Verwendung hochauflösender Radarbilder von Capella Space und Umbra, zwei privaten Unternehmen, die auf satellitengestützte Synthetic Aperture Radar-Bildgebung spezialisiert sind. Dadurch konnten Forscher ein 3D-Modell der inneren Struktur der großen Pyramide von Gizeh erstellen. Dieses Modell hat nun eine bislang unbekannte Kammer mit 5 horizontalen Ebenen und einem schrägen Dach enthüllt, die an sich schon eine architektonische Konstruktion darstellt, die in keiner Weise zuvor bei der Pyramide von Gizeh dokumentiert wurde. Doch die schockierendste Entdeckung liegt unter der Oberfläche. Unter der Erdoberfläche wurden durch Radartomographie vertikale zylindrische Strukturen identifiziert, die sich über Hunderte von Metern unterhalb der Pyramide erstrecken. Es gibt 8 dieser zylindrischen Brunnen, die in 2 parallelen Reihen angeordnet sind und bis zu einer erstaunlichen Tiefe von 648 Metern reichen. Noch faszinierender ist, dass sich an der Basis dieser Strukturen 2 massive kubische Formationen mit einem Durchmesser von etwa 80 Metern befinden. Die tomografischen Daten lassen darauf schließen, dass es sich um vertikale Brunnen mit komplizierten Spiralbahnen handelt. Dieses Design verfolgt nicht nur einen funktionalen Zweck, sondern weist auch ein hohes Maß an technischer Raffinesse auf, das das dynastische ägyptische Modell völlig in den Schatten stellt. Ich meine, die Pyramide selbst war bereits ein großes Warnsignal in der Geschichte des alten Ägypten. Aber jetzt, mit dieser Entdeckung, ist es meiner Meinung nach unmöglich geworden zu sagen, dass die ägyptischen Zivilisationen, die wir kennen und über die wir unterrichtet wurden, für den Bau dieser Bauwerke verantwortlich waren. Und das ist noch nicht alles. Die Radaranalyse erstreckt sich unter das gesamte Gizeh Plateau und enthüllt miteinander verbundene Strukturen nicht nur unter der großen Pyramide von Gizeh, sondern auch unter denen von Cheops und Menka. Das unterirdische Netzwerk reicht bis in eine erstaunliche Tiefe von etwa 2 Kilometer. Dies ist angesichts der gängigen historischen und archäologischen Darstellungen des alten Ägypten nicht möglich. Jetzt höre ich, dass da noch mehr kommt. Es gibt eine 4-stündige Präsentation, die vom Forschungsteam veröffentlicht wird. Das ist, was ich höre, und darauf werden ihre Ergebnisse eingehen. Im Wesentlichen handelte es sich hierbei um eine strategische Veröffentlichung unglaublicher Daten im Voraus, um das Interesse der Leute zu wecken. Und ich bin im Moment mehr daran interessiert als an praktisch allem anderen, weil dies bei weitem das provokanteste Beweisstück ist. Nicht nur für eine mögliche technologische Erklärung für den Zweck des Gizeh-Komplexes, sondern es liefert auch den außergewöhnlichsten Beweis für eine Zivilisation aus der Zeit vor der Sintflut, die auf eine Weise florierte, die wir kaum begreifen können. Es ist auch möglich, dass es sich bei dieser spiralförmigen zylindrischen Reihe von Strukturen um Treppen handelt. Und ich muss unweigerlich an die gechannelten Schriften von Thoth, dem Atlanter, denken. Sie wissen schon, die Smaragdtafeln, die von einer verlorenen Halle der Aufzeichnung sprechen, einer heiligen Halle des Wissens unterhalb des Gizeh Plateaus, den Hallen von Amenti. Könnte dies die verlorene Halle der Aufzeichnungen sein, die vor der Sintflut existierte? Diese Entdeckung ist offensichtlich äußerst umstritten. Sie steht im völligen Widerspruch zu den etablierten Narrativen und dem Status quo der etablierten Wissenschaft zu diesen Themen. Wenn diese Erkenntnisse vollständig belegt werden können, wird dies in der gesamten Wissenschaft und der Welt große Wellen schlagen. Aber die bisherigen Ergebnisse scheinen ziemlich eindeutig. Tief unter den Pyramiden und dem Gizeh Plateau im Allgemeinen finden offensichtlich bedeutende Bauarbeiten statt. Hat dies Ihre Meinung zu den Pyramiden geändert? Hat dies Ihre Position darüber gestärkt, was sie hätten sein können? Hat Ihnen diese neue Entdeckung neue Ideen zu den Auswirkungen gegeben? Lassen Sie es mich im Kommentarbereich unten wissen und teilen Sie dies bitte weit und breit. Das ist so interessantes Zeug. Vergessen Sie nicht, sich anzumelden. Wir werden einfach sehen, wohin das führt. Seien Sie versichert, dass ich alle kommenden Ankündigungen und Aktualisierungen zu diesem Thema sehr genau im Auge behalten werde. Dies spielt direkt auf eines meiner Hauptinteressen an, nämlich die Auswirkungen auf die prähistorische Zivilisation. Was geschah vor der globalen Katastrophe? Nun, ich denke, Momente wie dieser könnten Licht auf diese Frage werfen. Welche Zeit umzunehmen?
This is the world exclusive in the English world for the most earth-shattering discovery of the past. It might be the most earth-shattering discovery in history, and God knows what's going to happen after this.
With my technique, which is the maximum depthness that we can achieve, let's say around 5 kilometers. The first time we saw these shafts, we were, me and Corrado told me, Filippo, what are those things? No, Corrado, that's noise. The first day, the first week, the first month, but the second month we say, Corrado, we have changed the radar, we have changed images, we have changed everything, and always these shafts were completely visible. And so, how you say, by our consciousness, we announce it to everyone with a certain probability that is very high. People, there are the shafts.
So we are sure that under the pyramids are the structure we showed during the conference.
Mars, maybe Mars, that has dedicated missions that are at this moment orbiting around Mars. Why not? Can be very an opportunity to scan maybe something that is located on that planet.
This is not the first time that a possible existence of a city in the underground of Gizeh exists.
90-degree angles, spirals, rooms, something straight. No, they are not natural. I'm sorry.
The only way to better understand the purpose of the pyramids is the conjunction between archaeology and science. This is the only way to understand what happened in the ancient past.
So make that the 3D model. We have analyzed 1 year of tomographies, maybe 200 tomographies. 2 computers, 24 hours, 7 days were processing tomographies. So we have at least 200 tomographies acquired with different, let's say, tomographic lines, different images, and different satellite systems. Different everything, same results.
Today, I am speaking with Professor Filippo Bionde, who's also joined by investigative journalist and researcher Armando May, 2 members of the Khafra Pyramid Project, the team who recently stunned the world with incredible scans and 3D images showing spiraling structures extending deep below the Khafra Pyramid and across the Gizeh Plateau. Now, these claims have since gone viral around the world, inviting equal parts amazement and skepticism. And so today, I hope we can clear up some of the misconceptions and really get to the bottom of what the team believes they have discovered in Egypt underneath the sands of the Gizeh Plateau and the Khafra Pyramid. So Professor Filippo Bionde is a signal processing researcher specializing in synthetic aperture radar technologies. He has a PhD in telecommunications engineering from the University of L'Aquila, and he has held academic positions at institutions including Sapienza University of Rome and the University of Strathclyde in Scotland. His research is focused on synthetic aperture radar, or SAR technology, Doppler tomography, and underground imaging. And he is now dedicated primarily towards his project called Harmonic SAR, which aims to advance the overall development and deployment of SAR technologies, the same technologies that have been deployed in these recent studies of the Gizeh Plateau, which the team believes have revealed a massive network of subterranean structures extending below the Khafra Pyramid and the Gizeh Plateau itself. And joining him today is investigative journalist and researcher Armando May, who specializes in ancient civilizations with a particular emphasis on Egyptology. Armando contributes his archaeological and historical expertise to the Khafra project team, and it's great to have him with us. So it's a pleasure to speak with both of you. But Filippo, the findings from the team have caused shockwaves around the world. There's been a lot of excitement and there's been a lot of skepticism. So I hope that this conversation will clear the air for people so that we can have a better understanding of what you and the team behind the Khafra project have been doing. So there's been, like I said, a lot of critiques in the wider Western media from archaeologists and radar specialists saying that your claims of structures reaching 2 kilometers below the ground are not possible with the conventional technologies being deployed through synthetic aperture radar, through ground penetrating radar, that it's simply not possible for your team to obtain high fidelity imagery or signatures so deep below the earth. But as I've come to understand it through research and through listening to what you and the team had to say during your presentation in March, you're responsible for deploying a different technique, a different method from what I can understand. You have patented this method, applied for it in 2022 under the title of Synthetic Aperture Radar Underground, Undersea, Under Ice, and Inside Distributed Targets Tomographic Doppler Imaging. Now, that's a lot of big words, and I would really appreciate it if you could explain in detail how your method is different, because this is definitely the main critique I'm seeing. This is one of the big issues, and it seems to be based on the assumption that you are using the conventional techniques, but you're not doing that. You're using this patented method of your own, and I think it's worth explaining in as much detail as you can, and also try to explain so that people who are not scientists can understand as well. I think it's very important that the general public understand the difference between the conventional SAR scanning and these techniques that you're deploying.
Thank you very much. Thank you very much for your nice and very long presentation of ourselves. First of all, I would like to sorry for my English because I don't speak every day this language, but we will manage to do it well. Yes, I noticed that there was a bit of criticism about the technique we used for scanning inside pyramids. But I tell you that criticism was raised by people that weren't deeply inside of scientific world. I tell you, I saw a lot of debunkers, a lot of YouTubers, one physicist that I can't say her name, but never mind. And one professor of radar that is specialized in ground penetrating radar. We are a community of about 200 or 300 people. We are a restricted community, yes, but nobody told me anything about my technique, so that's good in my personal opinion. So I just want to punctualize something that is crucial for understanding well the technique that we have used in scanning inside the Gizeh Plateau. So this research started in 2022. At that time, we were me and Professor Corrado Malanga, that we was studying the Knum Khufu pyramid. We used in the past some synthetic aperture radar for scanning inside the pyramid. Then we had a lot of results, and then we moved, joining also Armando May in the community. We we founded this research group that is called the CAFRE Research, the CAFRE Project SAR Technology Research Group. So, according to this, I want to explain how technically my method works to everyone. So, so everyone can know how this technique works, and so maybe somebody can also replicate the experiments. It's well known that radar is the interaction of radar with or of radars with targets is only superficial. So electromagnetic waves interacts with matter principally superficially. So a synthetic aperture radar, which is a payload installed on satellites that are low Earth orbit satellites that orbits around the Earth at approximately 600 kilometers with respect to the surface of the Earth, has heliosynchronous orbital characteristics that in this case, radars scans the Earth and receives the response, the backscattering energy of the Earth. In this context, as I told you before, the interaction is only superficial. We can't penetrate matter using electromagnetic waves. Right. It's not possible. I repeat, it is not possible. A lot of years that I study synthetic aperture radar, so I have to tell you that synthetic aperture radar is completely different with respect to conventional radars. Synthetic aperture radar is another thing, because as the word announces, the name synthetic, it is something different. Why synthetic? Synthetic because we synthesize a long aperture in the azimuth direction in order to generate, sorry if I speak technical, but this is the moment, I think.
It's okay, no problem.
I'm sorry.
No problem.
To synthesize spatial resolution. What is the spatial resolution? The spatial resolution is a distance, so it's the minimum distance for which two targets can be distinct. This can be detected separately. Okay? So the more the spatial resolution, the better are the electromagnetic images that we want to produce of the Earth, because synthetic aperture radar, they are used for remote sensing in order to study the Earth, to capture electromagnetic pictures of the Earth. Okay. According to this, we are now moving in details about my technique. SAR images are produced in two steps. The first step is made by range focusing. Range focusing is performed by convolution between a chirp signal that I have as a reference with the electromagnetic impulses that I am receiving. Okay, so I have the first step, which is an image that is range focused. From raw data, we arrive to a range focused image. Okay, then we move to a middle step that is located between the first and the second. The middle step is called motion compensation. We have to compensate the location of the targets due to the motion of the satellite. Okay. Then we move to the second step, which is the azimuth focusing. And here acts my technique. Why? Because azimuth focusing is made by compressing the Doppler bandwidth. And the Doppler bandwidth is recast inside 0 Hz to maybe 20, 30, or 40 kilohertz, which are acoustic, which is acoustic information. So the azimuth focusing process is made by sound. Okay, by sound. Then, how works my technique? Instead to synthesize in order to have the maximum azimuth spatial resolution, we only use a part of the orbit to produce a lower azimuth resolution synthetic aperture radar image. But the rest of the orbit, we use the rest of the orbit in order to extrapolate, to grab from the Earth, from the Earth surface, the sound, in order to utilize the radar as a microphone,
right.
A giantest microphone that is located in the space. Okay? This microphone can ascoltare, how you say, hear, can record the sound of the surface of the Earth for 20 seconds, let's say 20 seconds, and recording this sound, we can say that it is a sufficient statistic in order to produce a tomographic image of the inside of the Earth. Why? Because the sound propagates only in matter. And here we are changing our mind, because we are not anymore using the electromagnetic waves, but we move to another point of view in order to process the sound information. And the sound information propagates only inside the Earth. And the sound interacts only with matter. Interacting only with matter and using a method for record this sound from space, we had a perfect condition in order to explore inside the Gizeh Plateau. So the Doppler bandwidth that we have estimated, it's let's say a completely acoustic bandwidth, so belonging between 0 Hz to 20 kilohertz. So it's perfect. We used the technique we used to invert the model. So once we have recorded 20 seconds of acoustic information of the Earth, of the surface of the Earth, we have used the so-called tomographic inversion in order to retrieve the acoustic focused photos of the internal of the Earth. This technique, first of all, was before to use this technique on the Gizeh Plateau, I made a lot of experiments. This technique born for performing the infrastructure monitoring of large bridges, right, in order to retrieve principal component analysis of vibrations of the bridge. In this context, we made a very interesting project in collaboration with European Space Agency in order to analyze this issue. And then you can see, if you go on the web, you can read my papers about the breach monitoring.
Am I correct that you also use this for the Gran Sasso National Laboratory and the Mosul Dam as well in Iraq?
Yes. Yes. I used the same technique. You can find the results on my website, www.harmonixar.com. And so where I have produced the inside scanning of the Gran Sasso. The Gran Sasso is a huge mountain where I born in L'Aquila, Italy, central part of Italy, where inside in the 80s, thanks to our professor Zikiki, who is a physicist, decided to build up a huge laboratory inside the Gran Sasso. Why? Because it was an optimal environment to study so-called muons or neutrinos. It is very interesting. Once I went to visit the laboratory, and the principal project that they are working for is called the GERDA project, seeking the Majorana particle.
Right.
It's very, very interesting.
I think it's important, and by all means, Armando, you can weigh in on this as well. But I highlighted this in a recent video. I think it's important to talk about the material composition of the Gizeh Plateau and the pyramids themselves. And it's my opinion, and perhaps you'll agree with me here, that the Gizeh Plateau's limestone composition and the pyramid itself, with the inclusion of rose quartz granite, might be creating, you could say, like an energetic coupling between the acoustic amplification of limestone, which obviously would create this mechanical stress, the piezoelectric effects of granite. Could this coupling effect of limestone and granite be assisting the amount of subsurface vibration that your team is discovering? Is the material composition of Gizeh unique for this type of study?
First of all, I beg your pardon for my English because, as Filippo said, it's not our first language. So
people will forgive you and understand, and they will appreciate that you're both making the effort to do this. So do not worry.
Okay, thank you. My first approach to the Gizeh Plateau, and particularly to the pyramids, start from the particular features of the monuments, because they are very, very intriguing, and in my opinion are not compatible with the tools and skills of the Egyptians during the Fourth Dynasty, and particularly during the ancient and Old Kingdom and the Fourth Dynasty. That is why I approach the study of the monuments from a different point of view, because I believe that monuments don't belong to the Egyptian civilization. But we also must better analyze these monuments from a scientific point of view, because all around the world, everyone says something about it. There are lots of theories about the pyramids, who built them, how the pyramids were built, but no one has a precise idea of what those monuments are. Pyramids of Cheops, for example, that is composed by sandstone from the great part, and the granite for the inside chambers, the chamber of the king, for example, and also by limestone. During my last investigation on the field, I noted, because this is a question that asked me Professor Corrado Malanga, that is the team leader of the CAFRE project, because he asked me, take a look to the base of the pyramids, because I believe there is something strange that you must investigate. And he refers to the platform on which the pyramids were built. See, the pyramids of Cheops, the pyramids of Khafre, for example, and the pyramid of Menkaure as well. Because all the three pyramids are based on slabs of limestone that penetrate the ground for at almost 6 meters in 16 meters under the surface. And we noted that exploring the underground of Gizeh using the SAR. And when we discover, and I'm referring to the Khafre pyramid, when we discover the coils under the pyramid of Khafre, we elaborated two kind of possible solution in the effort to understand why those shafts were built under the pyramids of Khafre. Maybe the first possible hypothesis is to port the weight of the monuments, okay? Because we made a study on the possible weight of the pyramids in respect of the base where it was built. And without these labs, the monument very likely would collapse. So this labs is very important limestone that is at the base of the pyramids, connected to the tubular, the coils that was in the underground. Another possibility is a technical use of the shafts, and maybe they are connected to the use of energy. But of course, those are also hypotheses that we must study scientifically, but exploration is very important. Why I'm saying that? Because in 2012, I was studying the pyramid of Khafre based on a mathematical and arithmetical model of analysis. And I approached particularly the sites of the monuments, elaborating by this model, mathematical model. And I noted that the monuments, the sites of the monuments are based on the first two prime number of the table of a prime number. That is to say, in the case of Khafre, the number 11 and the number 3. But what is very important is that that monument contains the number 137. And the number 137 is a basic number for physicists because it's the base from which originated electromagnetism, relativity, and quantum physics. And if there is this code in the pyramid of Khafre and also in the pyramid of Khufu, it means that this number was very, very important for the civilization of build that monument. So I believe that the only way to better understand the purpose of the pyramids is the conjunction between archaeology and science. This is the only way to understand what happened in the ancient past.
Yes, I agree entirely with that, Armando. Thank you. And something that a lot of people are asking, and perhaps you can both address this, perhaps Filippo, this be best addressed by you. The 2022 study on the Great Pyramid of Giza, this previous study, different to the one that was done on the Khafre Pyramid. Why did these structural anomalies that the team is now finding at the Khafre Pyramid, why did these not show up on the original studies? A lot of people online are wondering why these larger structural components, the spiraling columns and 2-kilometer deep signatures, a lot of people are asking why these were not detected when you were doing these original scans of the Great Pyramid.
Yes, thank you very much for this question. The 2022 paper, okay, let's say this. The 2022 paper results has been estimated using the same technique of today. What changed with respect to the 2022? Velocity. We have optimized the software. We have kernel. We have changed the kernel. We are now moving to make it run in GPU instead of CPU. So it is quite different, but the algorithm is the same. Just to tell you, John, the software is...
Oh, by the way, just real quick, I'm using my friend's Zoom. My name's Jay Anderson. John Major, he wouldn't say it's okay. John Majorowski's a friend. Thank you for letting me use your Zoom today. But yeah, it's very confusing, but my name is Jay. No, that's not your fault. I should have explained at the beginning.
Okay, Jay. I tell you, thank you very much. The software is complicated, but well structured. We need a lot of time. To synthesize the vibrations. Okay. Let's say we have two steps. The first step is synthesis, where we synthesize vibrations. The second step is analysis. Once we have the vibration, we just put down the curtain and we have tomography. It's very simple. 1 month of processing, 1 minute of processing. So those are the entity of the mess I call it. In 2022, we were only focused on Knum Khufu, only on Knum Khufu. We had the software 1.0, let's say 1.0 version, worked very, very good, but wasn't optimized in terms of computational effort. So we used to process only small and very dedicated tomographic lines. You can read it on the paper. So in some tomographies, we are looking a bit down. There are some coils like that, but we didn't have an open mind, let's say like that, to say no, because we were focusing our mind on the top of that pyramid. So we were seeking the big void, we were seeking the little void, we were seeking, and we found the corridor that belongs between the chevron and the Grand Gallery, which we found it for absolutely, and we were the first research group that found that corridor. And so we didn't focalize our mind in seeking something deeper. Because the software, we have to say, that has to be tuned. Okay, find things that are a bit on the top and find things that are deeply located on the ground. So also that, no, we have to say. Now, that today, because we have shifted our mind in scanning all the Gizeh Plateau, we tuned the software to say, okay, software, go where you can arrive, as deep where you can, and so things changed. I have to ask you this because people will ask you, and will ask you these questions. And to clarify this thing to everyone, which is the maximum deepness that a synthetic aperture radar, in terms of vibrational analysis, can investigate below the maximum deepness? I give you the answer. 0, because from the space, the power density is very, very little. And so if you use the energy transmitted from something that is 600 kilometers far away, it's not good. If you use a ground penetrating radar, which is a radar that is on the soil, on the earth, on the surface of the earth, and you scan like that manually, then you can arrive maybe 15 meters. But that's not the synthetic aperture.
Right.
We are speaking about radars that are located in space, which is another academy. It's completely different with respect to conventional radar. It's different, as I told you before. So, with my technique, that is let's call it modified synthetic aperture radar Doppler tomography, which is the maximum depthness that we can achieve. Let's say around 5 kilometers, like that. It depends on the Doppler bandwidth that we are synthesizing, okay?
Wow.
About 5 kilometers below. So we have tuned 2 or 3 kilometers, and we found these shafts that are very visible. And the first time we saw these shafts, we were, me and Corrado told me, Filippo, what are those things? No, Corrado, that's noise. The first day, the first week, the first month, But the second month, we say, Corrado, we have changed the radar, we have changed images, we have changed everything, and always these shafts were completely visible. And so, how you say, by our consciousness, we announce it to everyone with a certain probability that is very high. People, there are the shafts.
So, yeah, ahead of time, you released before that presentation in March,
Yes.
there was a series of abstracts and 3D graphics that were released. How confident are you that the 3D renderings, the 3D images of the pyramid structures that were released in the abstract, how confident are you that these images represent what is below the Khafra pyramid? Because there have been, again, critiques
Yes.
online saying that this is artistic representation. So how confident?
We thank people that critique, because critique is, in my personal opinion, always constructive. That's good. I give you the answer. I can tell you 90%. Why? So very high. Why? Because in order to perform, so draw, so make that 3D model, we have analyzed 1 year of tomographies, maybe 200 tomographies. 2 computers, 24 hours, 7 days were processing tomographies. So we have at least 200 tomographies acquired with different, let's say, tomographic lines, different images, and different satellite systems. Different everything, same results.
Wow. There have been comments from some researchers, including the theory that these might not be structural elements, but void spaces that we're seeing, maybe even filled with water. What do you think about these ideas that they're not structures, but might be spaces or gaps which have been dug down into deliberately, or connected into the water table and are filled with water? How do you address those claims?
I tell you this, in my personal, but in the opinion of the research group, are not natural voids, but artificial voids, because we have found the typical fingerprint of anthropic structures. So 90-degree angles, spirals, rooms, something straight. No, they are not natural. I'm sorry. I have to reject, but I thank always people that make critiques. I thank them because are always constructive, but I have to reject them. Thank you.
Now, Armando, maybe you can touch on this, because the history of Egypt and the history of the Gizeh Plateau, the claims of subterranean structures, underground labyrinths, this is not a new claim. This is not alone in a vacuum. This is quite a historically recognized, going significantly far back in time, from explorers and Egyptologists and archaeologists and scholars who have claimed this. So what would you say about the historical evidence regarding subterranean structures and sacred halls in Gizeh?
In fact, I have to say that I confirm that this is not the first time that a possible existence of a city in the underground of Giza exists. Because, for example, in 1930, an Egyptologist, Salim Hassan, stated in his work, Discovered Structures Beneath the Pyramids, he announced the possible existence of an hidden city under the pyramid. But also all these tunnels, corridors that originated from the surface of Giza, goes in the underground, were explored in the past by Hakim Abdullawian, for example, that explored the tunnels. Also Andrew Collins, that explored the tunnels originating from the NC2 tomb of the birds. So there are lots of study and research along the last century that could prove the existence of something in the underground of Giza. So we started from all these studies, And we approach a new model of analysis that lead us to discover these structures that are unbelievable, because Filippo is correct, because when we first saw what were the results of the detection of the star, we believed it's impossible. This is impossible, but we analyzed the subsurface for different points with different satellites, as Filippo told, and the results is always the same. So we are sure that under the pyramids are the structure we showed during the conference of March 16.
Well, it's just phenomenal. I mean, you know, this is the most significant discovery in human history regarding our own story, where we came from, what were we capable of in the distant past. This is obviously meeting significant scrutiny in the mainstream world because of the models and frameworks that have been developed over time. This contradicts those models, this contradicts those frameworks, and it's going to make some people very angry. In fact, how would you both respond to individuals such as Zahi Hawass, the former minister for the Department of Antiquities in Egypt, who's been pretty critical of the findings? He does not believe it to be true, and many of the archaeologists who are in the more traditional side are falling in alignment with that position. So how do you respond to those who are dismissing all of this and encouraging people, I would say, from what I've seen, to laugh at the very idea of this being possible? What would you say to those people?
We usually respond with data coming from scientific models, applying to our studies. We know with the announcement without any scientific value. So generally we discuss with people, and we make a statement all around the world, just only if we have the certainty that results are precise. Zahi Hawass, in my opinion, of course, is very well-known Egyptologist, and he worked extensively for his country to bring to light the wonders of the Egyptian civilization. Nevertheless, Hawass makes some statement in the last 10 days, but he was not well informed on the technology we were using. So I suggest him to learn before to say something that is not correct. Anyway, we are always open to the scientific community. We are ready to discuss with them to improve also our job that we are doing, because the cooperation between different field of investigation of scientific field is very important to move forward to the origins, to understand the origins of our civilization. So everyone are welcome, and the CAFRE project is an open world. So we are happy to receive the support of the scientific community to move forward in our job. Just for humankind, because humankind, I think, must know from where this civilization originated. And the Gizeh Plateau is many other sites, all the sites, archaeological sites in the world, are property of humankind and not of one person.
What can I say? I am studying radar for 30 years and working on radars also. We used poor science, orthodox methods, and hard working to retrieve. We are working on this project every day. We have used the scientific methods, that one of that is the experiments repeatability. We are measuring, we are just measuring and showing the world our results. Thank you.
Well, like I said, this is going to anger and confuse people who have been holding on to a very particular type of idea about Egypt, a very particular model about Egypt. And so having the resistance is to be expected, but the data should overwhelm the critiques, the evidence should overwhelm the naysayers, and that's what I'm very much looking forward to seeing with the development of this information. And hopefully you will be doing more scans and more work and more data collection. I'm assuming that you want to be taking this to other locations around the world as well.
Yes, yes, absolutely. And thank you for giving me this open question. Yes, of course, we want to move on other archaeological sites that are spread around the world. I don't know, let's say the other pyramids or the that are located in other parts of the world. So, I don't know, the Bosniak pyramids, let's say, something
Yes,
like that.
yes.
Very, very interesting site.
There's also
Teotihuacan, for example.
say that.
Teotihuacan.
Yes, yes. Teotihuacan, maybe Gunung Padang in Indonesia, and Göbekli Tepe as well is a very interesting one to get information on.
Yes, we already have some targets to detect.
Yes.
Yes.
Yeah.
And just to say, we are using equipments that are located in space. They are in orbit, in low Earth orbit, and we know that let's say other planets that are our neighbor, like Mars, maybe Mars, that has dedicated missions that are at this moment orbiting around Mars. Why not? Can be very, very an opportunity to scan maybe something that is located on that planet. Can be a nice topic.
We can put in orbit the SAR also Mars, for example, to detect the planet.
I think your team has been treated quite unfairly by the mainstream media. And like you said, there's been a lot of assumptions of the technology that's been deployed. And I think that this was a very unique opportunity to present the actual technology, the actual research by yourself and by the team and Armando. And hopefully this will dispel some of those critiques that were based on assuming conventional SAR processes, assuming conventional radar processes. I think you've explained yourself very well, and you know, your English, both of you, as much as you're worried about it, I think you came across very well, very understandable.
Oh, thank you.
No, you're most welcome, and you know, grazie mille, Filippo and Armando. It's been a pleasure to speak with you, and I wish your team the very best of luck. I hope we can stay in touch. If you have more to release, please get in touch, and I will do what I can to help. Chi non risica non rosica. Grazie mille.
Thank you very much.
And
thank you to you.
You're welcome.
Thank you.
Thank you.
Thank you.